Hello, Durban. Excellent. Excellent. Greetings from Santa Cruz, California, and I truly apologize for not making it to Durban. It just became near on impossible, but I'm also happy that the organizers were able to set up a Skype call. It is 5 o'clock in the morning here in California, which is why it's somewhat dark. And I actually left the house and wandered down to the ocean because as you are next to the water, I decided at least to be at one with the audience there. Oh, but you're all in a conference room and not by the ocean. Okay, let's move on to IPv6 because that's probably a much more safer topic to talk about. I'm going to have to say next slide to the audiovisual guys many times during this, and I'm going to skip a few slides. So let's see how that works. Next slide, please. Yes, that works for me. Okay, so I'm really going to just give you one simple part of an introduction. Next slide, please. I've been working on TCP/IP for 30 plus years now, and although I probably have seen quite a lot, I'm still pretty amazed at what happens. And some of the stats and some of the conversation I'm going to have here this afternoon will sort of cover some of the things that are quite impressive to me as we move forward. Next slide, please. And actually, next slide, because I'm going to hit the punchline. My goal is to tell you right from the start what we did and why it was good. And what we did was very simple. As a content delivery network, we are responsible for the IP addresses and the presentation of content out to the eyeballs, the last step, hopefully as close to the eyeballs as possible, which means that we also control the addressing and the DNS. And one of the things that was around for a long time on our service was IPv6, but it was very carefully controlled. The customer had to go on and manually request it. That is now changed. The punchline is very simple. If you're running any content via Cloudflare, we are now enabling IPv6 on every connection to the eyeball. Plain and simple, and that's it. So it's really quite a simple punchline, but we're going to go back. We'll hit the next slide and next few slides, and next one, please. And we'll talk about this. So the simple statistics on who we are and where the dots on the map are is on this map. We spread the globe, which means that we have very varied networks that we interconnect with. But there's a couple of important points to take back. Every dot on that map is connected to networks or internet exchanges and is always IPv6 enabled. And that's a key part as we move forward and talk about what we have done. Everything else, we're going to skip through some marketing slides. So when I say next slide, I think I'm going to say that a few times. So next slide. Next slide, next slide, next slide. We'll go through these. They look like marketing slides. We'll skip through them. One more. One more. Now, down to the technical parts. Right. Now we're down to the part I like the best. So the technical parts on this are actually the parts that most people, I would hope, with inside SAFNOG are interested in. We have done this major change to the outbound DNS where we're v6 only. We have got a bunch of stats that are useful, but then we sat and looked at the results of this and realized that we weren't quite there for the whole v6 story as a content delivery network. So we have some next steps. Okay, next slide, please. Next slide. All right, so a content delivery network like Cloudflare is a phenomenally brilliant bridge between the v4 world and the v6 world. If needed, you can take v4 content, bring it in through a content delivery network, which if you think about how a content delivery network works, it's a TCP connection towards an origin, towards a web server that is somewhere, let's say, whether it be on a cloud service provider, a hosting service provider, or even inside an enterprise or ISP environment. And yet the outside of the content delivery network has a brand new TCP connection, much closer, hopefully, to the end user, and yet can connect on v4 and on v6, independent of the original connection. These are two separate sides to the content delivery network. There's no reason for them to be the same protocol. They normally both, well, no, they both run HTTP. They can both have secure connections, but there's no need for them to have the same protocol family. Next slide, please. And in order to do that, in our setup, 6 years ago now, we placed a switch on our user interface which had the on or off capability. If you take the next slide, please. When you turn the switch off, which is, and this is the key part, which is was the default, then you end up only with a v4 outbound connection. Now, in the world of mobile, as we'll see later, with large number of v6 connections coming up over LTE networks and the like, this changes. It simply is not the way to go. You need to enable v6. But as I said earlier, we had this switch as the default of being off. Next slide, please. And with it off, we made one simple change. If you leave it in the off position or flip it to the off position, we put up a silly little message that simply said, hey, I think you're going to the old version of the internet. Now, this is very cute and interesting, but it truly doesn't solve the problem. And we needed some way to force, quite frankly, this large user base onto v6. Next slide, please. And next slide. So this, sorry, we went one too far. If I go back to the one with the black text, perfect. In this environment, we went through our database of users with this very simple algorithm, which I will describe. In our user interface, everything is transactional. In other words, we know that you've set up an account, that you've added a domain, that you've added a DNS record, that you have turned up HTTPS options, you have enabled certain other options, including the v6 switch. So we were able to go to millions upon millions of accounts and say, have you ever been to the IPv6 configuration page? If you've never been to that page, which means you've never flipped the switch to enable v6, maybe we can assume, and this is a big assumption here, but this is the part that wins, we can assume that the user is somewhat oblivious of the need of v6, or maybe simply it doesn't matter to them. Remember, we live in a world which for years upon years upon years, Facebook, Google, and many other services have been v6 enabled by default and work. So we're sitting on the shoulders of giants, to use the phrase, but more importantly, our own website, Cloudflare.com, and many of our own services have been v6 enabled, and therefore we know that that is a clean working environment. So this piece of code here, very simplistic code, or pseudocode I should really say, says as simple as this. Let's take every user that's never looked at the v6 switch, and let's flip that switch. Let's enable v6 as if that was the default on day 0. And we basically said, we'll keep this under control, so we'll only move 100,000 domains a day. And that will slowly bring this into play. Next slide, please. And so we started this in the back. We didn't really talk to anybody about this because we didn't want to. We did a couple of things that you'll obviously recognize. We made sure our support people knew what was going on. We knew our network people already understood this. But this is what happened out in the Twitterverse, basically, is people noticed. A few people will monitor the Alexa million list or other lists and sort of go, let's see how many websites are v6 enabled. Well, it turns out we've got 6, 7 now, more than that, websites on our service. We seem to have quite an effect on the Alexa list. And as you can see, these graphs are sort of doing my favorite thing, going up and to the right. And if you look at the graph on the right, you'll see quite a blip there, which the question was asked before we mentioned anything, what's going on? Next slide, please. Here's a larger slide showing really the difference that we made. I've got the start and the end date on this slide. And you can tell that we moved the Alexa million list quite significantly into the v6 enabled world, and we're quite happy about that. What I don't have is a slide that shows you the number of support calls that came in, or support emails. And the answer is because there really wasn't any. This is one of the key things about IPv6 in this day and age. We simply are able to enable v6 and not deal with the support issues that we dealt with many years ago. Remember, the original use of World v6 Day and World v6 launch was to deal with understanding where the problems were. And that's well behind us now. Next slide, please. Here's a sort of graph of the amount of v6 traffic on our network. Of course, it goes up and down every day, but the good news is that we obviously increased not only by adding v6 to DNS, but we added traffic, and I'm going to show that in other ways later. Next slide, please. Right, so next slide. We decided to remove the switch. Now, this was, again, the next big step in what we did. The first step was to make all these manual changes to existing customers. And by the way, we had also changed the default to be on versus off during that period. So there is by default a v6 world. But the second part was, if you see the before and after, is we removed the switch. We simply took away the ability for somebody to turn off v6. And that is a very key takeaway from what I'm talking about today, is that we basically realized that there is no reason to have the switch there anymore in this day and age. Now, the little star and the comment at the bottom says, yeah, actually there is a way to adjust it. There are certain customers and high-end customers that have certain needs, and a lot of that comes towards geolocation inside the v6 world and the need for better geolocation databases. But I can honestly say that even that is now going away, slowly but surely. Next slide, please. All right. So let's look at some statistics. The first part of the talk was simply, we've now enabled v6. The second part of the talk is, let's have a look at what that actually means. And I've got a bunch of graphs here. I hope the PDF shows up on the SAFNOG site so you can sort of look at it afterwards, because I'm going to skip through a bunch of these and get to something technical at the end. Next slide, please. So we went through and looked at some of the. We went through and listened to where the traffic was coming from, and I want to call out certain countries. Belgium, no ifs, ands, or buts. Absolutely high amounts of v6 traffic. Why? Because the mobile carrier there has done a large amount of work in enabling v6, as has some of the home broadband connections. So sort of we get top marks. We see stats that other people see in there. Next slide, please. But we also see stats that look a little strange. Why is Ireland number 1 or number 2 on our list? And it actually turns out, we're going back to that geolocation thing. It isn't really Ireland, but it's Facebook. And Facebook is a rather interesting beast. When you post something cute, whether it be a cat or otherwise, on Facebook for your friends to see, you've got to remember that Facebook is essentially crawling the URL that you gave them to put up the picture and to put up the initial text and the like. And that crawl is done heavily over v6. If you're familiar with Happy Eyeballs, and I'll talk about that a little bit in a moment, then you realize that Happy Eyeballs is where you try to get more V6 than connections than V4 by doing 2 TCP connections. Well, it seems that the guys at Facebook have really got very happy eyeballs and definitely are moving in the V6 world. So we see a large number of stats, and this is purely automated crawling of websites that we see. So we can discount that from end users. Next slide, please. I'm going to skip through some of these. Japan, look at the long-term graph there. Absolutely going in the right direction, and again, you're seeing this in the mobile and broadband worlds of finally deploying stuff. Next slide, please. Now, this, I hope, is somewhat visible and readable on your screens, but if not, then again, I reference you, but it's a more interesting slide than most of the others. What I have here is, on the x-axis, I have bandwidth. The amount of bandwidth, the relative size of a network. On the left, it's 0. On the right, it's a lot. And in the y-axis, it is the percentage of V6 traffic seen on a particular network. Now, you may want to look for your favorite network, but I'll tell you, these are only the major networks. There's an enormous amount of smaller networks with low V6, which are clustered in the bottom left-hand corner, that are removed from this graph because they become too messy to see. This graph has value in the sense that it enables you to sort of look at how certain providers are faring. Now, their size is a relative dimension of how big either a country or a marketplace is. That's fine. But the V6, the vertical size, is rather important. We see things like AT&T Mobile, we see T-Mobile in the US, we see Deutsche Telekom in Europe. And to be honest, yes, I would like to see some of the South African and other African providers here, but at the moment, quite frankly, we're not seeing that. But that isn't the subject of my talk today. It is simply to show the positive side of this and to show that there are providers that have this. But look at these numbers. For the networks that are V6 enabled, they're below 50%, or they just simply aren't 100% with very, very few exceptions. And all the exceptions here are special cases. This is what I'm going to talk about at the end of the talk, because why aren't these networks that are V6 enabled, why aren't they all up at the top of the graph? Next slide, please. I'm going to skip a few of the statistics slides. Do we really care too much about the different networks in a different format? No, we can move on to the next slide, please. Next slide, sorry, that's the replication of data. Device types. If you notice, the mobile devices are really winning in this game. That may be obvious because, one, they are newer platforms, and they're updated fairly regularly. And secondly, if they're on mobile networks that are running LTE and running V6, then that's why you're seeing it. Next slide, please. No difference, not much difference between iOS and Android. That used to have a difference. It's sort of going away. Next slide, please. And then there's Windows. And you know, I've looked at this graph a bunch of times and tried to come up with something really cute and insightful to say about it. To suffice to say, there's a lot of people out there that aren't really upgrading Windows, and that has nothing to do with V6. Next slide, please. We see DNS traffic with V6. That's no surprise there. We see certain amounts of floods where we see attack traffic on V6. This is not a DDoS mitigation talk, so I'm sort of going to skip delving into that. But the point is, we do see the spread. Next slide, please. Okay, and next slide again. All right, so we see an awful lot of unique V6 addresses. In fact, we see an enormous amount of unique V6 addresses if we dump them into a database, which becomes quite a beast to manage. It does not actually mean that they're really unique, and I think this is again an understanding of how V6 operates. But we definitely, if we can match them against the DNS queries we see, we don't see very many unique. We see a very finite number, is a better way of saying it, of unique DNS queries. Next slide, please. All right, where do we see it on the world? Well, again, all the usual suspects. We do see V6 heavily in Europe. We do see it in certain parts of Asia. We do see it in North America, with some stuff in South America showing up. And of course, we'd like to see more. We are seeing some in Africa, but possibly, in my mind, not enough. But keep in mind, I'm highly biased on that subject. Next slide. There's a few of these graphs here. We obviously see the higher percentages of traffic showing up in places like Europe, more so than even North America. Next slide, please. All right, so I'm going to skip this one. This will make people who go to IETF meetings laugh, but next slide, next slide. Yeah, all right, next slide. So let's talk about what's next. Let's finish up on this subject here. We'll hit the next slide, please. So if you remember on that graph, I talked about when I showed the bandwidth and percentage of V6, why were these percentages not higher? And in a lot of cases, when you delve down to it, you actually realize that we're sitting in this multi-step process now that V6 is real in the world. We're having to do DNS queries for A records, the V4 address for a particular website. And then we're doing a DNS query for V6. Now, we can nearly do them at the same time. They're asynchronous, but they're two round-trip queries. And until we get a response, specifically if we need a response to the quad A record, we can't set up a TCP connection and do an actual transfer, which is the only thing the end user wants to see. Next slide, please. These need to become one. Oops, somebody jumped me back lots and lots of slides. Oh, perfect, there we go. So what we have gone through is a set of conversations with inside the IETF. And I will put a side note here is if you're interested in making the internet better, get involved in the IETF. It's easy, it's free, it's the right thing to do. So we've been working with inside the DNS groups, inside the IETF, inside the V6 groups, and what we have basically been putting together as a proposal is that any DNS query for an A record has some ability to also return a quad A record for free. Now, there are actually some interesting problems with this. No protocol design is easy and simple from the start. And I'll, if I go to the next slide, please, and ignore the details of this, but we have working code. This is up live. You can go do a DNS query, if you can read that on the screen, for a website like Taylor Swift. Should you be a Taylor Swift fan? Actually, you can do the DNS query even if you're not a Taylor Swift fan. And this code has the ability to be used by DNS resolvers to reduce the round trip time significantly. In other words, doing two queries for one. And it's interesting that we've taken this long in the evolution of V6, which is essentially 20 years, to sort of realize that maybe the stumbling block of V4 queries is one that we should deal with. Next slide, please. Now, in the good nature of the IETF, we put a proposal in on how to do this with a method, as did two other groups, two other people. And although we hope you pick, ours and this goes through the IETF, it's a slow process. The reality is that it shows that a few people have realized the exact same problem. And so we're pushing for this. And the net result of this is that we're looking to speed up and to improve the ability for clients, for end users, consumers, to actually have a browser and device that will get a V6 path. That really pretty much sums up what I want to talk about. The next slide or the last slide. is a big thank you. I hope that I have kept you awake, even though I'm doing this remotely. And I have no idea whether my face is on the screen or not. But I will gladly take questions if that can be organized through the various audiovisual paths.
Thank you, Martin. I hope you had the loud clap from the audience here. So
I did. Thank you.
Good. Now, any questions for Martin? Okay. We have one. Come to the mic.
Hi, Martin. My name's Alan Levy. I'm from the Internet Society of South Africa, and we've been using IPv6 for some time now, and most websites work fine on IPv4 and IPv6. But as was shown very clearly by Jan's NAT64 web test, there are certain Java scripts and back-end PHP scripts and various other bits and pieces of websites that sometimes do break when delivering over IPv6. So it's very hard to believe that you had no complaints or no support calls or no failures or everything went totally smoothly. It sounds a little bit too good to be true. Can you share with us some of the pain?
Yes, I can, absolutely. First of all, you've absolutely hit the number one flaw in what I just spoke about. I was by far talking about the positive, happy side of everything we did. There obviously were issues, and in fact some of them we knew ahead of time. So let me tell you about the one specific issue. We have a large number of hosting providers or otherwise that maybe bring hundreds of thousands of domains onto us. And we have a couple of them that have issues. You actually mentioned something very interesting. You talked about, PHP and the like. We find that if we have somebody who has no back-end processing for dealing with a long address, in other words, anything other than a v4 address inside their log files or their database, v6 will absolutely cause them problems. But it causes the hosting provider problems, not the end user, the consumer of the bits. So it is a purely back-end problem, and yes, we've seen this. So we do have a couple of hosting providers that literally admit that they've got PHP code from 10, 12 years ago that no one has any faith in updating, and that's their log processing and to a certain extent maybe their accounting software, such that they will not or they have a hard time in enabling v6 because their back end can't handle it. It has pretty much nothing to do with the front end, to do with the consumer on a mobile device or on a tablet or on a laptop. It has to do with the back end. And we've seen that repeated a few times. And at some point in time, and I say this as politely as I can to customers, at some point in time, and I say, if you haven't touched code in 10 or 15 years, maybe you have other issues over and above v6 to deal with. And that's the truth. The other thing you mentioned, you talked about the NAT64 environments and the like. I think that for most regular web properties, this is not so much of an issue. But for specialized applications, whether it be gaming or certain media applications, including ones like Skype that I'm using today, then yes, there is a difference, and something will have to be done to special code v6. But for most web properties, absolutely not a problem.
Okay, any other questions? All right, seems like there is no other question. Just a comment, observation rather from myself. So it seems like anyone who wants to do v4 or actually wants to keep the switch on for v4, v6 needs to pay you more.
I don't see a problem with that. There is actually there is one singular class of website that we have a hard time dealing with, and that is things like Jason's test IPv6 website, where he explicitly needs v4 and v6 only URLs. We removed that option for him, and I'm okay with that. This isn't needed for what we do these days, and I would gladly work with any customer to make sure that that any v4 dependencies are carefully removed. They're nearly always on the far side, because remember that providing a quad A record outbound on a v4 only connection really is completely ignored. It's plain and simple.
Great. Thank you very much.
Great. Thank you very much, and I'll come join you guys at SAFNOG again, and I do apologize for missing this meeting. And now it's about still not 6 o'clock, so I'm going to go head back and get some more sleep. Take care, everybody. Bye-bye.
All right. Thanks, Martin.